So this is going to be an organic chemistry mind map. So we're going to start with calcium oxide plus 3 carbon heated with 2200 degrees Celsius temperature, which will give us calcium carbide. So from here, with help of H2O, we will get ethane. So now that we got ethane, we need to react it with ferrous or iron to get our well-known benzene. So we can write it as this, or we can simply draw a hexagon and put a circle in the middle of it. So we can do it because we can represent the delocalized electrons, pi electrons actually, among the 6 carbon. We can represent it by this way. So now that we have our benzene, we are going to have some reaction of benzene. So I'm going to do this, and let me put okay, so I have got it here, and now we will start the reactions of benzene. So the first one is going to uh, to be make cyclohexane. So to do this, we will take help of 3 hydrogen and nickel with 200 degrees Celsius temperature. So now that we have this, we will get our cyclohexane. There will be no ring between the hexagon. It is our cyclohexane. Okay, so I'm going to put the name beside it, so it might help to look at cyclohexane. That's it. So now we are going to our second reaction, which will be to make ethanediol, or known as glyoxal. So the glyoxal is CHO. So to make it, we will take help of ozone, O3, and zinc and H2O. So it is our glyoxal. So here are some basics which will be needed in our further reactions. So let me put it in there. We have hydrocarbon, if we can do two reactions there actually. One is, okay, so I think it will be easy for the first one, uh, which will be oxidization. So if we oxidize a hydrocarbon, it will become alcohol. I'll be back with the second reaction after completing it. Okay, alcohol. uh, if we further oxidize it, so oxidization means to add oxygen with a third bracket in it. So okay, so if we oxidize the alcohol, we get aldehyde and ketones. Sorry. Okay, so if we further oxidize it, we get our acids, and it will be organic acid. So now that we have done our oxidization reactions, we'll be back with our reduction reaction. So if we do reduction reaction with the acids, and reduction mean to add hydrogen with a third bracket. So it becomes aldehyde and ketone. And if we do further, it becomes alcohol. Sorry. And with a further reaction, let me put it come back to hydrocarbon. So it is a basic you will need to know for our further reactions. Okay, it is, so let me put it the name here. It is glyoxal or ethanediol. Okay, oh, I think we have made our second reaction, so let's move on third reaction. So for our third reaction, we will make a gamaxine. Now we might not know what gamaxine is. So gamaxine is a hexagonal structure but no ring between it. And we will give a chloron to every hand of it or every point of the hexagon. Remember, there is no ring between it. It's important. And it is our gamaxine. Okay, so I will put the name later of every compound, so it won't take much time. Okay, so we have made our third reaction there. So here the catalysts are 3 chloron with the help of sunlight. So our third reaction is done. So our fourth reaction is important one, which is Fidelkraft alkylation. So put it in there. So for our Fidelkraft alkylation process, it will be a bigger one. So here we will get toluene. So you might wonder what is the structure of toluene. So toluene is a benzene-like structure with the CH3 on top of it. So that's it for our catalyst. There will be okay, let me put it in there. Chloromethane CH3 Cl chloromethyl and aluminum chloride AlCl3. Okay, there, and with help of 20 to 30 degree Celsius temperature. The name of the reaction is Fidelcraft alkylation. So okay, I'll put it here later. We first complete the reactions. Okay, so let's move to our fifth reaction, which will be um, the product will be chlorobenzene. So we need some basic here. First we will get some basic and come back to it. So another basic is that of a benzene. Okay. Okay, so this two two place will be called ortho position, and these two position will be called meta position, and the opposite of the hand will be called para position. So here O means ortho, P means para, and M means meta. Okay, so it is important. Oh, so there is a important thing there, that it is important where we put the functional group, because if we put the functional group there, then this two will be ortho, then this okay, this two will be meta, and the opposite will be para. So it is really important that we know where we're putting the functional group. So now that we know that, uh, let's give our catalyst. So the catalysts are chlorine and ferric chloride. I hope you know that this is ferrous chloride and this is ferric chloride. Okay, so moving to our sixth and I think seventh, yes, sixth reaction. By the way, okay, let me put it here. CO3. This process is called chlorination. I'll put the name later here, so it will be easy for me. Okay, Going to our sixth reaction, it is sulfonation. So the product here is benzene sulfonic acid. Okay, so it looks something like this. Yes. Okay, and the catalyst is 2 sulfuric acid. The process is sulfonation process. And the next one is making nitrobenzene. Yes. Sorry. The catalyst are okay, nitric acid and sulfuric acid. Okay, that's it. We will have further reactions from these elements and compounds, but first complete this reaction, I guess. And the last one is Fidelcraft acylation. Remember, this one was Fidelcraft alkylation and this one is Fidelcraft acylation. These are two completely different reactions. Okay, so the product here will be acetophenone. Okay, the catalysts here are okay, the catalyst CS3COCl, actually CH3COCl, which is known as acetyl chloride, and aluminum. Okay, aluminum chloride. That's it. That's our reactions of benzene. And now we will move to our further reactions. Okay, but first let me put the names here so it will be easy to remember. I have put all the names here, which will make your reading easy. So something important here is that these two are different and important reaction. One is Friedel-Crafts alkylation and one is Friedel-Crafts acylation. So with Friedel-Crafts alkylation we make toluene and with Friedel-Crafts acylation we make acetophenone. So okay, we will move to our further reaction with our glyoxal. So with the glyoxal we will do oxidation, which means input oxygen with third bracket, and as we have seen there that it is a kind of aldehyde. Okay, so if we oxidize aldehyde we will get acid. So here we will get acid. The acid will be oxalic acid. So let me put it here, oxalic acid. So okay, we got our acid and move to our next reaction. So now that we have got toluene, we will get many important reactions from toluene. So let's move. Okay, pretty far. Okay, so it is the oxidation of toluene. So the process will give us benzoic acid. So let's make our benzoic acid. It is our benzoic acid. Here the catalysts are KMnO4 and S2O slash H plus ion with the help of heat. Okay, so it is our first reaction. The second reaction is Itard reaction. Okay, so we will get benzaldehyde from Itard reaction, which is CHO. The catalysts here are CR2. Okay, small maybe. Um, okay, I haven't put the ring here. Sorry for that. So the catalysts are CrO2. Okay, small mistake. Cl2 and water with heat. That's it. Okay, so to move to our third reaction, the product will be, it is a very important reaction or maybe a new kind of reaction. So let me put it in here. So you will get two products from here. Products are, okay, this one is orthonitritoluene. Remember I told you that wherever we put the substitution group, or sorry, functional group, the point beside it will be ortho and the opposite point will be para, and these two will be called meta. So it is ortho nitrotoluene, and another will be made, which is paranitrotoluene. Sorry. Okay, it is our paranitrotoluene. So okay, our reactions of toluene is done. We will get an important reaction from here. Okay, we'll put it back here, but first let us make diazonium salt. To make diazonium salt, we will have to take nitrobenzene and put it in reaction with nitric acid. Sorry, it will be nitrous acid with HCl and 0 to 5 degrees Celsius temperature. It will give us diazonium salt. Oh, remember that you can also write it as this, but I'm more comfortable with this one, so I'm writing it as this. If you write it as this, the ortho position will be this, and para position will be this, and meta position will be this too. Okay, now let's remove it. Since I am writing it as this, my ortho positions will be this, and para position will be this, and meta position will be this. So you can write however you feel comfortable with. Just remember the basics. So we have got our diazonium salt. Here is okay. So this is the far I have come. We have more reactions actually. I will solve them. I next videos I guess. Okay, so I think I will have to put it in part 1, or I will slowly update this chart and make it complete one day. So till then, see you.